Radiation from X-ray procedures is good because it helps to diagnose problems with patients. But sometimes radiation can cause harm to the patient and even lead to death. Radiation has the ability to cause a wide range of damaging effects, including cancer, cataracts, skin burns, genetic diseases, hair loss, and diminished sperm count. All of these damaging effects can be organized into just two categories: stochastic effects and deterministic effects. Stochastic effects include things like cancer and genetic mutations. The word stochastic simply means random and unpredictable, which is a good description of these effects. That's why stochastic effects are sometimes called probabilistic effects, because whether or not these effects happen is based purely in probability. At low doses of radiation, stochastic effects like cancer are possible but not likely. As a person's exposure to radiation increases, the probability of acquiring a stochastic effect increases, but it's never a sure thing. Stochastic effects could be compared to being in a car accident. Every time you drive, there is a chance that you could get into an accident. If you're only driving a few miles across town, the chance of getting into an accident is small, but there is a chance. If you're driving several thousand miles, the chance of a car accident increases significantly, but it's never a sure thing. This is exactly like the stochastic effects of radiation. As an individual's radiation dose increases, the chance or probability of acquiring a stochastic effect also increases. Stochastic effects are like car accidents in another way too. If you do get into an accident, the severity of the accident is unrelated to the number of miles you drove. An accident is no better and no worse just because you had only driven a few miles. Cancer and other stochastic effects are like this as well. The severity of the accident, or the radiation-induced cancer in this case, is not affected by the dose that caused the cancer. A cancer caused by a small radiation dose is no better and no worse than a cancer caused by a larger dose. Since stochastic effects are random and unpredictable, it makes sense that deterministic effects are just the opposite. They are very predictable. Deterministic effects include things like cataracts, skin erythema, epilation, and decreased sperm count. All of these effects occur only at specific dose thresholds. For example, diminished sperm count occurs only at a radiation dose of 150 milligray or higher. Compare that to skin erythema, which occurs only at 2,000 milligray or higher, and hair loss, which occurs only at 3,000 milligray or higher. Deterministic effects are like damage to car tires. As you drive your car, the rubber on the tire will show no visible sign of damage and no negative effects, but only up to a certain point. At a fairly predictable point and under predictable conditions, the tires will show obvious damage, the performance of the tire will be affected, and the tire can even explode. Once this threshold is crossed, more driving results in more damage. Deterministic effects are like this. Radiation exposure causes cell damage, but that damage is not visible until it reaches a specific threshold. Once that threshold is crossed, higher doses results in more harm and can eventually lead to death.